Hi there, and welcome back. What we're going to do in this video is find an antiderivative that requires the use of U-substitution. In other words, reversing the chain rule. So we have the antiderivative of x squared times the quantity 4x to the third plus 5 raised to the sixth power. And what signals us to use U-substitution for this is that we have a function within a function. In this case, it's a quantity that's being raised to a power. That's what's telling us that it's a composite function. So we are going to let u equal 4x to the third plus 5. And then the differential form is du equals 12x squared dx. Now notice that we do not have a 12x squared dx in the integral. We just have x squared dx. That turns out to be the most important part. We can work with constants. It's just that the variable piece does have to be there. So since x squared dx is in the integral, I am going to go ahead and isolate. Somehow my x got cut off there. There we go. I'm going to isolate x squared dx to one side. So this means that 1/12 du is equal to x squared dx. So then u equals 4x to the third plus 5 is going to replace this piece, and x squared dx becomes 1/12 du, and we're going to have a whole brand new integral with u as the variable instead of x. So we have the integral of u to the sixth, and x squared dx is 1/12 du, and that integral sign is a little bit too far away for my taste. How about that? So now we know that the 1/12 can go outside of the integral by the constant multiple rule. So we have 1/12 integral of u to the sixth du, and now this is where the power rule is going to be used. So we have 1/12 times 1/7 u to the seventh plus c, which is 1/84 u to the seventh plus c, and then u is 4x to the third plus 5. We need to remember to write our answer in terms of the original variable. So we have 1/84, 4x to the third plus 5 to the seventh plus c, which of course can also be written as 4x to the third plus 5 to the seventh all over 84 plus c. So either one of those two forms is acceptable for a final answer. And there is an integral using U-substitution.